Okay, so moving on, we're going to talk about conditional probability and the general multiplication rule. One thing to note, guys, we talked about conditional probability in the student work problems on the last section. So if you see those, it's the thing where it says P F/E, and you might not have had the formula for it, and you will get it in this section. I'm sorry. I gave the solution to it, and you'll see it as number 1, I think, in the solutions on the last section. So let's get going. General information, we talked about independence and the occurrence of one event having no effect on the probability of a second event. Obviously, this won't always be the case. For instance, the probability of being in a car accident change based on driving conditions. Of course it does. If it's snowing, you're more likely to get in a crash, or if it's foggy, different things affect driving conditions, and so your probability is higher, and that's how they calculate insurance costs. Conditional probability obesity. So according to the Center of Disease Control, 1/3 of adults in America and 1/3 of adult men in the United States are obese. The probability is 0.33 that any randomly selected male is obese. However, 28% of middle-aged men are obese compared to 40% of adult men between the ages of 40 and 59. So 2 different age groups, sorry. The probability is 0.28 that an adult male is obese given that he is age 20 to 39, or 0.4 given that he is 50 to 59. Probability changed based on the age group, therefore not independent, and this is called conditional probability. So at the beginning of the video, this is what I was talking about. The conditional probability, the notation P of F/E, which means the probability of the event F given that event E has already occurred. For example, the probability of obese is given that 20 to 39 is equal to 0.28, and the probability of obese given that 40 to 59 is given as 0.4. Okay, so there's actually a formula for that. Suppose that a single die is rolled. What is the probability that the die comes up 3? Now suppose that the die is rolled a second time, but you're told the outcome will be an odd number. What is the probability that the die comes up 3? The probability of rolling a 3 is 1 in 6. If you know the roll is going to be odd, what is the probability now? It's changed to 1 in 3, and so we know that the probability has changed, and therefore it's not independent anymore. Okay. Determine the probability that a randomly selected person, 15 years or older, is widowed. Then compute the probability given that the person is a widowed female. So 15 or older is widowed. It would be anybody who's widowed. There's 14.3. Then compute the probability given that the person is a widowed female. So that'd be 11.2 out of 14.3. And how do I know that? Well, okay, so here's the formula for it. We have P of F given that E has occurred is equal to P of E and F, so the intersection of E and F, and divided by the probability of E. So if we look back to here, the probability that the person is widowed is 14.3. It's not a probability, it's a number, so this is the n version of it. And so that's 14.3, and then compute the probability that the person given is widowed female. Well, widowed female is the intersection of widowed and female, that's 11.2 divided by 14.3. And that's where this comes from. This was this formula, not this one. Okay. I usually just use P. So if I use P when it should be numbers, then sorry, shame on me. Example problem. Work this out on the next slide. It has the solution. So compute the probability that a randomly selected individual has never married given that they're male. So the intersection of never married and male is 41.6. but the probability that they're male is 122.5, so that's 41.6 over 122.5. And so you can see that right here. Now if we go back, compute the probability that a randomly selected individual is male, given that the individual has never been married. So we want male, never married, that's 41.6. But given that they're never married is 78.5, so then 41.6 over 78.5 in this case. So you can see how it changes. Okay, the one that's given is always the one that you divide by. Suppose that 12.7% of all births are preterm. The gestation period is this, also 0.22% of births are preterm. So I'm going to work this out real quick, and then I'll start a new video for the next one. Thank you guys.